Okay, so here's your chart about quadrilaterals. We filled this out over 8.2 through 8.5. Just to recap, you need to know how a parallelogram is a rectangle, which is a rhombus, which is a square, and everything, how it works out. You just need to really pay attention to what is the specifics and everything else. On your theorem sheet, you do have the information. So the biggest thing for today's lesson is, in your notes, you're going to get walked through a chart and answering questions, and then 2 quadrilateral proofs, which are coordinate proofs, like we did on Friday if you were in class on Friday. And then Tuesday's lesson will be the second day of that. It will just be more practice since I preloaded the information on Friday for most students. If there is a snowstorm, I don't know what's going to happen, but I'm just giving you a heads up. We may scrap the second day of 8.6. But with that, you just need to make sure that you are doing what you need to do. So, biggest thing is with what is going on, I just want you to make sure that you understand. You have to be able to identify pretty much everything that is on this sheet with your theorem sheet. So to start, the classification with another flowchart, just kind of a different look at it. Excuse me. The biggest thing is the quadrilateral is a set of shapes, and they break down into just quads, or you have kite, trapezoids, and parallelograms. Underneath parallelograms you have a rectangle and a rhombus, and underneath both of those you get the square. Underneath the trapezoid you have an isosceles trapezoid where legs are congruent. So, a quadrilateral DEFG that has at least one pair of opposite sides congruent. What types of quadrilaterals meet this condition? At least one side congruent. So parallelograms have both pairs of opposite sides being congruent. And remember, the key word is opposite sides here, so parallelograms would meet this. Rectangles would meet this. Rhombus and square would meet this as well. The isosceles trapezoid would also meet this because of the fact that opposite sides are congruent. Opposite legs, to be specifically the non-parallel sides. But trapezoid and kite would not meet that criteria. So here's the next one. It's giving the most specific names. Explain your reasoning. You have to start from the very beginning. So you have to jump through quadrilateral to everything else. So based on number 2, these two sides here of RU and TU are congruent. RS and ST are congruent. Opposite sides are not parallel nor congruent, so this would be a kite. Excuse me, my nose is running. On number 3, you have one pair of opposite sides being parallel, so you have at least one pair of opposite sides being parallel. Based on that, you have a pair of parallel sides. The definition of a rectangle is 4 right angles, but you could use diagonals are congruent to prove that, excuse me, my nose is running. They are also a rectangle if you have congruency. Since this is 62, 75, and 64 and 80, the measurements do not add up for diagonals, so diagonals are not congruent. So therefore, this trapezoid is not an isotrap. It's just a trapezoid. On number 4, you have, excuse me, my nose is running. These two being congruent. So you have opposite sides being congruent. You have a diagonal that is bisected and marked congruent. So due to vertical angles, let's see. I want to say this is just a quadrilateral because there's not enough information to say that EF and CD are congruent. You don't have enough information about this diagonal here. Opposite sides aren't congruent or parallel, so this is just a quadrilateral. You don't have enough information. So the next thing you have is this chart. To figure out what gets filled in this chart is literally basically going to your flowchart that we already created and then marking what is congruent. So with that, all sides are congruent. The items that allow all sides to be congruent would be a rhombus and a square. So this is true and this is true. Sorry, my nose is running. Both pairs of opposite sides are congruent, so parallelogram, and that's a symbol for parallelogram, a rectangle, a rhombus, and a square. Keyword being opposite. Both pairs of opposite sides are parallel. Definition of a parallelogram. Rectangle, rhombus, and a square are a parallelogram. Excuse me, my nose is running. So exactly one pair of opposite sides are parallel. Exactly one pair of opposite sides are parallel is the definition of a trapezoid. Let me focus out of here. Because it's really poorly transposed, the autofocus is not wanting to pick it up. There we go, it's a little bit better. All angles are congruent. So all angles are congruent when you have a right angle. So 90 degrees, so that would be a rectangle and a square, not a rhombus. Exactly one pair of opposite angles are congruent. So exactly one pair of opposite angles are congruent. One pair only would be the definition of a kite, or a property of a kite. Diagonals are perpendicular. Diagonals are perpendicular in a rhombus. So then that also holds true for a square. Diagonals are perpendicular also in a kite. Diagonals are congruent. That is a part of a rectangle. That is also true in a isosceles trapezoid. But since isotrap is not on this list, that's not a part of it. Diagonals are congruent in a square as well, because it is a rectangle. If you thought of isotrap here, this would be isotrap, but once again, this is a trapezoid, not an isotrap, so that would only be true in an isotrapezoid, but not an actual trapezoid. Diagonals bisect each other. That is one of the parts or resulting ideas from a parallelogram, so these would all hold true because they are parallelograms. Diagonals bisect each other. So the other one that the diagonals bisect each other is, that's it. So there you go, that's your chart. So on the back side, and if I'm wrong, I will totally give you the right answers in the book. I'm just going off of this right now at X time of night. I do know that it is pretty late, and I'm not making that excuse that I'm correct or if I'm wrong, but I'm just trying to hold true with what the book says. So the next thing we're going to do is we're going to do points Q, R, S, and vertices of a quadrilateral with the most specific name, a P, Q, R, S. So the two I'm going to do with you are 21 and 23. They are in the back of the book. So 21 is the one we're going to do here. So P is going to be red. So 1, 0. Q is 1, 2. I think I'm doing a different color. 1, 2. R is 6, 5. So 2, 4, 6, 5. 2, 4, 5. Oops, if I graph that one right. That is not 1, 2. 1, 2 would be right here. And then go pink. 3, 0. 3, 0 is here. So connecting these. So this looks like a kite, based on my drawing, roughly. It is quite a possibility that it is a kite. So, based on my wonderful numbers here. So PQ is opposite, PQ is opposite of RS. So RS peak. So those two are opposite each other. PS. So PS is opposite QR. And I'm trying to color code just to keep track, and I'm probably only going to do one of these on here. But the biggest thing is, when you're doing this, is to keep track of what is going on. So it looks like a kite, so the first thing I have to do is disprove it being a parallelogram, which I can quickly do with its 4 slopes. If none of the slopes are forming, or excuse me, if none of the slopes are exactly the same, then I don't have parallelogram. That means I can play the game of, is it a trapezoid or a kite? Once I know that, and none of the sides are parallel, then I know it's probably a kite. When it's a kite, I have to prove at least 2 consecutive sides, or excuse me, 2 consecutive sides are congruent to another 2 consecutive sides, and opposite sides, which I wrote, are not congruent. So, and parallel. They also wouldn't be congruent. So if these slopes are not parallel, and their distances are different, then that means I'm on the right track of being a kite. Pretty much the rule of thumb is 4 slopes, 4 distances of your segments. And once again, I did color code. Excuse me. So I can kind of keep track of that. So, let's see. I'm use a pencil line for my slopes and anything that is not related. So, pencil line. P is red, so wherever I see P, I'm going to put P points. Remember, Y's go over on top, so this is 0, 1, 0, 1. I guess I could put minuses in here, because you're going to subtract with your slopes. And the second point I will put in parentheses. So Q is 2, 1, so 2, 1, and Q here is 2, 1. R is 6, 5. So, sorry, Q is 1, 2. I switched it. Erasable pens and pencils just are not friends. Well, we'll just go with it. 5, 6. 5, 6. And last but not least, S is 3, 0. So 0, 3, 0, 3. So, doing my slopes, I write those final answers in orange. 0 minus 2 is negative 2 over 0, which is undefined. 5 minus 0 is 5 over 3. 0 minus 0 over negative 2. That one's 0. And then 2 minus 5 is negative 3 over negative 5, which equals out to be 3/5. QR. Okay, so undefined and 0 are slopes that are perpendicular. Perpendicular slopes allow you to know that you have some 90 degrees going on because they're perpendicular lines. Excuse me, I was trying to double check my notes here. And then the other 2 slopes, they aren't the same. They're not opposite reciprocals. They don't have anything to do with each other, so don't really care about them. Now comes the distance formula. So the trick with the distance formula, if you don't recall from in class on Friday, or you were not here on Friday, is x minus x squared plus y minus y squared. You don't have to do the subtraction again, because slope, if you recall, is y2 minus y1 over x2 minus x1. So before you simplify your slopes, this y2 minus y1 is the same as this one, and this x2 minus x1 is the same as this one. So what you can do is literally take the numbers when you do your subtraction, before you do any simplifying, and take those numbers and put it in as the product. Not the product, excuse me, the difference. So instead of rewriting out the distance formula and going 0 minus, or excuse me, starting with x's, 1 minus 1 quantity squared plus 0 minus 2 quantity squared, and getting 0 squared plus negative 2 squared, which gives me 0 plus 4, square root of 4 equals 2. I could have just started here at this line. So on here for RS, I'm going to go 5 squared plus 3 squared. I know the order is switched. This is y's and these are x's, but it doesn't matter. This gives me the square root of 25 plus 9, which gives me the square root of 34. Do not need to simplify it down, just need to have a number at the end, which means I did not have to simplify the square root of 4 to 2. So coming here, I have the square root of 0 squared plus negative 2 squared, which gives me the square root of 0 plus 4, which gives me the square root of 4, which equals 2. Last but not least, I have the square root of 3 squared plus 5 squared, which gives me the square root of 9 plus 25, which gives me the square root of 34. So, not a parallelogram. Due to opposite sides not parallel. So therefore, my next idea is a kite. No parallel sides. And I prove it's a kite. Two sets of sides are congruent. Opposite sides not parallel. So the most specific name for this shape over here is a kite. All this work is worth, I want to say it's a 5-point question, and the way it works out is each slope is a half point, each distance is a half point, because you pretty much need those to prove it. So essentially, to prove based on slopes, each work set is a half point. To prove on distances, either rectangles or sides, is worth a half point, and then your name at the end is worth 1 point. Your work has to match your final name. So another one to do would be number 23, and I'm going to do this just based in pencil without color coding. So 23, I have P at 2, 7, so 2, 7, 2, 4, 6, try it again, 2, 4, 6, 7, 1, 2, 3, 4, 5, 6, 7, okay, so that's P. Q is at 6, 9, so 2, 3, 4, 5, 6, I'm at 7, up 9, so that's Q. R is 9, 3, so this is 6, 7, 8, 9, and I'm going to go down to 3. So here's R, and S is 5, so 6, 5, and go down to 1. So this is S. So if I sketch this out, definitely does not look like a trapezoid, and definitely does not look like a kite. So I'm going to play the game of parallelogram. So Once again, I'm going to go PQ, SR, PS, QR, and I'm going to start with slopes. So P's point was 2, 7. So I'm going to go 7 over 2. And so over here, I'm going to go 7 over 2. Q is 6, 9, so 9, 6. 9, 6. R is 9, 3. So 9, 3. 9, 3. So I need to switch these because it's 9, 3 and make it 3, 9 because I didn't do y's over x's. And the reason why I knew I did that wrong is because 9 minus 9 is 0, and this slope is definitely not 0. And then P, nope, did P, S. S is 1, 5, 1, so 1, 5, 1, 5, and I'm going to double check, 2, 7, 2, 7, 6, 9, 6, 9, 9, 3, 9, 3, 5, 1, 5, 1, okay. X's will go on the bottom, Y's go on the top, so 7 minus 9 is negative 2 over negative 4. 1 minus 3 is equal to negative 2 over negative 4. 7 minus 1 is 6 over negative 3. And 9 minus 3 is 6 over negative 3. So looking at my slopes, these all simplify, but these two numbers are the same and these two numbers are the same. So I know that opposite sides are parallel. So right now I'm at a parallelogram. So going back to my chart, I now have to decide, excuse me, is it a rectangle, a rhombus, or a square? So the first thing to do is look at a rectangle, because rectangle has 4 right angles based on slopes, and I haven't done distances of sides yet. So based on a rectangle having slopes, I need to figure out 90 degrees. So 4 right angles means I have opposite reciprocals for my fractions. So looking at my fractions right now, I can't tell that. So what I'm going to do is I'm going to simplify these. So this equals 1/2. This equals 2 over negative 1, 2 over negative 1. So this is 1 over 2, this slope is 2 over 1, and this is negative where this is positive. So that means lines are perpendicular. So opposite consecutive sides are perpendicular. So I know I have 4 right angles. Consecutive sides are perpendicular, so I'm at a rectangle. So how do I know from here if I have a rhombus, or actually more specifically a square? And it cannot be based off counting boxes because your rectangle is slanted, and it cannot be based off of just looking at it. So you actually have to prove that either all 4 sides are congruent or not congruent to disprove a rhombus. You could prove about diagonals being congruent. However, diagonals are congruent in both rectangles and squares, so that doesn't work. That is one way that you could prove this here. So what you actually have to do is, to disprove a square, you have to prove that sides are not congruent. So, distance formulas. This is a prime example where you cannot do the distances off your simplified because all these distances here would be exactly the same. You have to go off your original distances. So if you're doing the trick with distance formula and not using the original points that are up here, excuse me, my nose is running, you would use negative 2 plus negative 4 squared. Now, these two distances will be the same. So I'm only going to do the math once, but I am going to write it out twice. You could just do it based off consecutive sides, because we already know opposite sides are congruent. If you prove consecutive sides not congruent, therefore it won't be a rectangle. So I really only care about SR and PS, because those are my consecutive sides. But rule of thumb, like I said, if you can't remember what you need to do, distances of all four sides are what you're looking at. But the measurements of the two middle ones are the ones that I care the most about, because this distance is the same, this distance and this distance is the same. So this would be 4 plus 16, so this is the square root of 20. This is 36 plus 9, which is the square root of 45. Since consecutive sides are not congruent, I don't have a rhombus, so not square or not rhombus, and I'm writing this down so you understand, but looking at it you wouldn't have to do anything to show that. Since all sides are not congruent, therefore it's just a rectangle. That's 8.6. There will be a worksheet for you that has the shapes already on it, and then you'll have another worksheet for you the second day of math class. So 8.6, you'll have a worksheet just from me. That is what was assigned on Friday, or given to you on Friday. If you're gone on Friday, there will be a handout for you. And then for day 2, we'll have a book assignment and another little half sheet, but we will play it by ear for what Tuesday's assignment will be.